Okay, chapter 8.6, factoring where a does not equal 1, meaning there's a coefficient here on x squared. So this first example, 3x squared plus 4x minus 15, 3x squared plus 4x minus 15. When I see that, when I see this 3, which is a prime number, and I see this 15, which only factors a couple of different ways, 1 and 15 and 3 and 5, I'm going to go with guess and check. In other words, when there's not a whole lot of different options here, and there's only one option here, I'm going to use guess and check. I want to show you how this works. So in factoring this, we know we have a trinomial. We know we're going to have some type of a thing that looks like this. We know we're going to have a couple of x's here. We know that because this is 3x, we're going to need to have a 3x or 3x squared. We're going to need a 3x and an x. That's the only way we're going to get 3x squared. There's no other option because 3 is prime. Then over here with the 5, or with a 15 rather, I know we're going to either have a 1 and a 15 or a 3 and a 5. So we might try a 3 and a 5 here, or a 5 and a 3 here, or a 1 and a 15, or a 1 and a 15. Now notice I'm putting them in opposite positions because it matters where the 3 is in comparison with those. Now also we have a minus sign here, which means we're going to have two different signs, and our O and our I term, our in FOIL, our outers and our inners, are going to be subtracted from one another to get positive 4x. So now we just kind of guess and check. So notice that the 3x squared we're stuck with our 3x. And this last 15, if we put a 3 and a 5 in, or a 5 and a 3 in, or a 1 and a 15 in, or a 15 and a 1 in, we will get the 15, right? And if we make the signs different, we'll get the negative, right? But how do we get the 4x is the deal here. How do we get the 4x? So this is where the guess and check works. If we were to put a 3 here and a 5 here, we got to check the outers and the inners for the 4x. So this will give us 3x, this will give us 5x. We're going to have a difference. Oh, no, sorry. This will give us 3x. This will give us 15x. This will give us 3x. This will give us 15x. So our difference is going to be 12x. That's not 4. Here, we're going to have a 5x and a 9x. A 5x and a 9x. So when we do the inners, we get 5x. We do the outers, we get 9x. Oh, well, 5x and 9x, the difference of those will be 4x. So we're going to go with that. I'm going to put the 3 in here. Put the 5 in here. Notice I'm not going to bother to check the 1 and the 15, but the 1 would produce 1x, the 15 would produce 45x, right? So that could be 44x as a difference. If we put the 15 over here and the 1 over here, this last row, the 15 over here and the 1 over here, then we would have 15x and 3x. So that would be a 12 again, right? So here's what we have. We have 5x and 9x. We need to make this positive. So we need to make the 9x positive. So we have a plus sign here and a minus sign here. And we're done. I'm going to erase while you think about that, I'm going to erase with these options so that we use the same piece of paper in a minute to do a different type of factoring. But that's the most efficient way to factor still. Guess and check is the most efficient way. But if this was a number like 60, which has lots of different options, and this was a number like 8, which has some different options, this becomes really difficult. But when you have a prime number and a number that's only done a couple different ways, this isn't so bad.